So this is going to be covering some of the questions that some of you asked regarding the Standing Waves Lab. So it's going to be divided into two parts. This part will be the frequency versus harmonic number and their relationships, and maybe like how to fill out your super summary. The first thing I'm going to talk about is the graph that you should have gotten about your relationship. So let's start off with the graph. So it should have looked something like, well, you've got your x here and your y here, and it should have been something like this. So in your Desmos graph, maybe your slope doesn't look quite nice like this, but that just means you have to rearrange or reframe the slope of the line. So in math, usually the slope is called k or m, and so I'm just going to use k for now. So just remember that that's your slope. And to get your slope, I believe what you've been doing in algebra is something like change in y over change in x, more commonly known as your rise over your run. All right, so this is something you know, maybe you've called it m, but it's still slope. And when you type it into Desmos, you maybe type it in as y sub 1 tilde k times x1. And this is what we would call a direct variation, okay, or a linear relationship. These are all words that you've used all year. All right, so what does that mean? The equation is actually y is equal to k times x. So we changed the y1 to just regular y. The tilde now becomes an equal sign. K is the slope, and x1, or x sub 1, is now just plain regular x. And remember that these are placeholders. X and y are placeholders. You have to replace them with something that it actually means. So since we're talking about the frequency versus harmonic number, our x was the harmonic number, and our y was frequency. So we're just going to replace y with frequency. That's very thick. And then k, I'm going to hold off on what k means, so we'll just keep k there. And x is our harmonic number, so we'll just call it its full name, harmonic number. And you all got various numbers for k. So k for some of you was 10, or I think someone got 13.5, maybe you got 11.1. Whatever that number is, you'll use it for k. You'll replace that number with k. So we have f is equal to, then your k, I'm going to use 10, and then times the harmonic number. Okay. Now we also need units in here. Okay. So what does that mean? Our units for frequency was hertz, and we didn't really have a unit for harmonic number because we just counted the number of harmonics. So hertz was our rise units over our non-existent really units for harmonic number. So what we get is our slopes units are hertz, okay? Units for slope. So we're going to rewrite our equation. Frequency is equal to 10 hertz times our x, which is harmonic number. So all of this should go into your mathematical relationship between variables. Okay. now moving on, we are going to talk about the quantitative relationship. So the quantitative relationship really is, what does your slope mean? Okay, so once again, I'm going to be using K is equal to 10 hertz. So what does your slope mean? And if you remember, so we had our frequency and we had our harmonic number here, and it made this nice direct linear relationship. And so our K is 10 hertz. Remember, slope is rise over run. So really it was 10, 1. So for every time I moved over 1 this way to the on our x-axis, it also went up by 10 on our rise axis. So when we write that in a sentence, it might be something like, as the number of harmonic number increased, the frequency increased by by 10 hertz. Well, I should have said, as the number of harmonic number increased by 1, comma, the frequency increased by 10 hertz. The relationship shows a direct and linear relationship. I guess that's redundant, but I'm sure you could say it better than I can. Okay, so that's our mathematical and quantitative, some of the more problematic parts of our labs. Another part that I also noticed is that this is for the written relationship part. In the written relationship, written relationship, it's, let me see if I can make this font bigger actually. Okay, we'll just leave it there. So when the blank increases, decreases, the blank increases, decreases. All right, so what you're supposed to be doing here is fill in the blank. You should be filling in the blank. So fill in this blank and fill in this blank. Usually the first blank is what your x is doing, or your independent variable. Okay, independent. And then this is your y. Like, what happens when you changed your x? And then what you need to do is pick increase or decrease. Don't pick both. Pick one or the other. So maybe my x increased, so I will get rid of the decrease. And my y also increased, so I will get rid of the decrease. So when I rewrite the sentence, it's when the x increases, the y also increases. And that's all you're really doing for the written part. Okay, and then the prediction example. So let's go back to our equation that we wrote. Okay, so our equation was F is equal to 10 hertz times the harmonic number. So we have F is equal to 10 hertz times the harmonic number. And what we're going to do is replace the harmonic number with some number. So this is your x. So you're going to replace x, that's x, with a number or value that you didn't collect originally. That wasn't originally collected. And so you're going to be predicting what that frequency would be. So my frequency, and if I wanted to find 10 harmonics, or maybe I'll go with 9 harmonics. So if I wanted to find 9 harmonics, I could find that frequency around 10 times 9 is 90 hertz. Okay? And so that would This whole part right here, that would be my prediction area. Okay, and so that covers our super summary for the frequency and harmonic number relationship.